Okay, this is the last lesson in Chapter 6, Lesson 5, and we're talking about the third and final format for writing a linear equation, and this is called standard form or general form. In this format, so we're going to just focus on standard form. Standard form equation looks like this, so it's kind of different from the other two we've learned. So just as a quick review, we learned y equals mx plus b. That was the slope-intercept form, and we learned the slope-point form, which was y minus y1 equals mx minus x1. So those were the formats of equations we've learned so far, and this one looks a little bit different because this one, the x and the y are on the same side of the equation, and there's a purpose for this. This one is particularly good when you know the intercepts, both intercepts, the x and the y intercepts. This time the numbers a, b, and c don't actually have any much relevance in terms of like telling you the slope or a particular point, but what you can do from this equation is find the intercepts really quickly. So let me show you how that works, and we're going to graph the equation, and then we'll do a word problem. Okay, so here's our equation, 3x plus 2y equals 18. So this is in standard form. Now what we're going to do is find the x-intercept first. So remember that the x-axis is here, and all along the x-axis, the y values is 0. Because remember the y-axis is here, so the y value is 0. So what I'm going to do is essentially cover up or pretend that the y value is 0 in this equation and solve for x. So if the y value was 0, I would essentially have 3x equals 18 because that y would go away. Divide by 3, and I get x equals 6. So I know that the x-intercept of my equation is 6, and I can graph it right here. X-intercept. Okay, equals 6. All right, let's do the y-intercept. Okay, on the y-axis, which is here, all of the x values are 0 on that line. And so in our equation, we're going to essentially pretend that x is 0, and we're going to solve this equation. So divide by 2. So we get y equals 9. So the y-intercept will be 9. Okay. And then once we have our two intercepts, as long as you have 2 points, you can draw a line straight through them. And that's our line. So it's going to look like something like, and I'm going to try my best to make it nice and straight. There we go. So there's our equation. So the numbers 3, 2, and 18 don't necessarily tell you anything about the line, but they do help you get the x and y intercepts really quickly. So here and here, you essentially just pretend the y is 0. We don't pretend. You set the y to be 0 for the x-intercept, and you set the x to be 0 for the y-intercept. Okay. Let's look at converting some equations between different formats. Now that we know all three formats, it's useful to be able to convert because we can find out different information about them. Okay, so first we're going to practice going from y equals mx plus b into standard form. And just as a reminder, I'm going to have it up here. It looks like this, ax plus by equals c. So I'm going to have to get the x and y all on one side, and also a and b and c are all integers, meaning there's no like fractions or decimals. Okay, so first thing I'm going to do here is move the 2/3 x to the other side. And the golden rule in math is this: as long as you do something to one side and you do the same thing to the other side of the equation is equivalent. So it's going to look like this. Now here they canceled out, so I'll just be left with 4. It's starting to look like the standard form now. I just have to get rid of that fraction. So to cancel out that fraction, I'm going to multiply everything by 3. When you multiply, you need to do it to every single term in the equation. So here I'll have 2x plus 3y equals 12, and that's my standard form. There we go. Okay, let's do the same thing over here. This one's going to take a little bit more work because I'm going to have to get rid of the brackets first, then move my x term over, and then get rid of the fractions. So first thing I'm going to do is expand that bracket. Just go one step at a time and slowly start to make it look like the other type of equation, 6 over 5. Now I'm going to move the x term to the other side. What you do to one side, you have to do to the other. And the other thing I'm going to do is move this 1 to this side. So this is what it'll look like now. Negative 3 over 5x plus y equals, and just on the side here, I'm going to do 6 over 5 plus 1 would be the same as 6 over 5 plus 5 over 5, which would be 11 over 5. So on this side, I'm going to have 11 over 5. Okay, last thing I'm going to do is cancel out those fractions. I'm going to multiply everything by 5, and I'm also going to use a negative 5 here because you want your first term to be positive when you're writing standard form. That's just a convention. So here the 5's will cancel out and we'll have 3x. Here we'll have negative 5y, and here the 5's will cancel out and I'll have negative 11. There we go. Okay. Let's go the other way now. So let's say we're given an equation in standard form. How can we change it to figure out the slope? So we want to determine the slope of this line. This is actually in general form when all terms are on one side and you have a 0 on the other. So we want to try to get it into a slope format. So y equals mx plus b is the easiest one. And then we can just read off the slope. Okay, so let's move some of our terms to the other side of the equation. Let's subtract 3x from both sides. And I'll have negative 2y minus 16 equals negative 3x. And then I'm going to add 16 to both sides. So I'll have negative 2y equals negative 3x plus 16. I can't add those two because they're not like terms, so I just write them separately. And finally, I divide every single term by negative 2. You have to divide every term when you're dividing, just like you did when you were multiplying in the example above. So we'll have y equals, so those negative signs here will cancel, so I'll just have 3 over 2x minus 8. 16 divided by negative 2 is negative 8. So that's my slope-intercept form, and my slope is right there. 3 over 2. You could also write it as a decimal. 1.5 would be fine as well. Okay, let's see how a word problem looks when you want to write standard form. So it's usually set up in the same way. I call these like counting problems or total, when things total up to something. So let's have a look. We have a bag of peanuts costs $2 and raisins cost $1, and Devin has a total of $10 to spend on some snacks. So here we have like a total problem. We have a total amount of something that we're adding to. When it's in this kind of format, we want to use standard form. And this is how I usually start my equation. I start with the answer. We know we're going to have a total of $10 to spend, right? We're going to buy some number of peanuts and some number of raisins. Let's define our variables here. Let's say the number of peanut bags let's call that X, and the number of raisin bags, let's call that Y, okay? So we have $2 times the number of peanut bags that we buy, we don't know that number, would be 2 times X plus $1 times the number of raisins we buy has to add up to 10. So that's how you set up your equation. Just like that, and it's in standard form. So let's graph it. When we graph it, we're going to look for the intercepts. So for the x-intercept, we're going to pretend that y is 0, or we're going to set y to be 0. So we're going to have, it's essentially if you're just buying only peanuts. If we're buying only peanuts, how many bags would we buy? And here we'll put peanuts. and we'll put raisins here. Well, we would buy 5 bags. So let's go up by 5s this way. 2, 3, 4, 5. 2, 4, 6, 8, 10. Let's go up by 2s. 2, 4, 6, 8, 10. Okay, so that means my x-intercept will be 5. And the y-intercept, I don't have much room on that side, so I'll do it over here. It's essentially saying, what if we only bought raisins? Well, we can just do this logically. If I only bought raisins, they cost $1 each, and I have $10 to spend, it's going to be 10 bags of raisins. I'm going to put 10 bags of raisins there. And then I'm just going to draw my line. There we go. Okay. So some other points on that line would be, now if I drew this properly, it would be, we actually shouldn't draw like a straight line through it because you can only buy like an integer number of bags. You can't buy like half a bag. So you could buy 8 bags of raisins, 1 bag of peanuts, 6 bags of raisins, 2 bags of peanuts, 4 bags of raisins, 3 peanuts, 2 raisins, 4 peanuts, or only 5 bags of peanuts, right? Those are our only options. So we actually shouldn't draw a line through there because there's no decimal numbers of bags allowed here. Now it says, what if Devin purchased 2 bags of raisins? So raisins here, 2 bags of raisins. So here, how many bags of peanuts? Oh, we can just read it straight off the graph. 4. Right? Okay, so you definitely want to use the standard form when you have this sort of totaling up problem where you're like spending a certain amount of money or adding to a certain amount, and then you have like 2 different types of things that are adding to that amount. Okay, and that is the end of the final lesson.